All right, students, welcome back for another little bit about Java. Today we're going to talk about Java programs. All right, yesterday we kind of talked a little bit about our Hello World program, which simply just displayed the message, Hello World. Um, let's go ahead and talk a little bit more though about what Java is and what it does, and how programming languages work. So Java is an object-oriented programming language, as mentioned previously. Another term you might hear thrown around is high-level programming languages. The reason why they're called that is because these languages tend to be easy for the programmer to understand and to write. Compare this against machine languages, which are languages that the computer can directly understand. Think about things like binary or hexadecimal. In order for Java to be run on the computer, it first has to be translated using what is known as a compiler. And the process of transforming your code, like that Hello World program that we wrote, into the language that the machine understands, so binary, hexadecimal, whatever it's going to use, is known as compiling. Now, an advantage of Java. Java uses a built-in interpreter and compiler to the native language of the machine is being used for, so whether it's Windows or whatever. This language that Java does produce is what's known as a bytecode. Right? Remember when you press the start button in Eclipse? This executes the run command on the Java virtual machine. The program we are writing is called the source program or source code. The program that the computer actually executes is called an object program or object code. So let's look at our Java program. When you create a program in Java, you are creating classes that must be compiled in order to run. So let's say we make a program called first program. Then the file on your computer is actually going to be called firstprogram.java. So if you notice, we only have one class right now. All right, it's that main class. But eventually, we're going to get into implementing additional classes. All right, we can compile our code in order to create the resulting bytecode. So let's use our firstprogram.java example that we just talked about. Once we compile it, we're going to see another file appear that is called firstprogram.class. Right, this is the bytecode file. Right. Syntax and semantics. Now, before I mention this, right, we've actually already done a little bit with this piece because in the video, I had a second follow-up video that talks about taking that program and uploading our little Java file into the assignment section. So that way you know, hey, what is this code that I'm submitting? Is it the .java file, .class file? I told you exactly which file you need to do. And going forward, that's what you'll submit to me, and then I'll run the code and test it. All right. Now, back to syntax and semantics. Just like any written language, right, programming languages have a set of rules they must follow. So just like English has a set of rules, Spanish will have a set of rules. All these languages have grammar rules, right, and other things. Java is no different. The most important thing is syntax. This is the arrangement of words and punctuation that are legal to use in the programming language. And by legal, I don't mean like it's against the law. I mean legal meaning that it's not going to throw an error in your code. Later on, when we examine programming errors, syntax errors are going to be the easiest things to find, as they often prevent your code from compiling. It's like they're going to stick out like a sore thumb. Eclipse will throw a nice big red line there and say, hey, you got a problem here. Semantics. All right, these are the meaning of the words that are written in your code while following syntax rules. So what does it mean? The semantics tell me, like, what does class mean? What does public mean? What does system mean? Semantics help define a lot of that stuff. Now, let's talk about those errors. I kind of already mentioned of them a little bit, but let's talk a little bit more about it. So here's our Hello World program. Right? Now, if you look at it, some of you might look at it and say, hey, I'm noticing right away that there's an error in the code. How many of you have seen it at this point? Go ahead, pause the video, take a second, and see if you can figure out what the error is in this code. Any errors that are in a program are known as bugs. The process of fixing said bugs is called debugging. Now there are three types of errors, and I'll come back to our Hello World program here after we talk about this, just see if you can have figured it out. All right. The first is a syntax error. All right. These are a grammatical mistake. So in our previous Hello World example, the code was missing a semicolon at the end of the system.out.println statement. So there's the answer. We look back at our code. Sure enough, if I flip back here, you can look right here and see right here by Hello World, there's a semicolon missing. That's a syntax error. If we were to try and compile this, Eclipse would say, I can't work with this because there's something missing. The next kind of error you'll get is what's known as a runtime error. This is an error that's not detected until your program is run. So like your code might look good, but you go hit that little green play button and it says, I got an error. The computer will display an error message that you may not necessarily understand, but it will give you an indication that something's wrong. As we get into more into coding, runtime errors will be easier to solve at this current time. Not probably going to encounter them too much, but it's good to be knowing about them. Now, this last type of error is going to, as we get into more into programming, is going to be the bane of your existence, and that is logic errors. Logic errors are a mistake in the underlying algorithm. Your program will run, and it's not going to display any errors. But what you're expecting to be your output will not be your output. It's going to be undesired. It's going to be wrong. Like if you, I'm going to give you a quick, easy example. Let's say you have something that's going to add 2 and 4, but it gives you the answer 5. Like, wait a minute, something's wrong. Obviously, your code would be a lot more complex than that, but it's going to work along those ideas. Now, these errors are typically the hardest to locate because the computer is not going to give you any information about those errors. Right? A good quick example of that, the most common one I see is when we get into loops and we use curly brackets, and people are so in the habit of using semicolons that they just stick a semicolon right at the end of their loop declaration, and they never get to access the code that's inside the curly brackets. All right, here we are on our self-test questions. So you have a couple here. So go ahead and answer these. Number 1, what is a compiler? Number 2, what is a source program? Number 3, what is an object program? Number 4, what do you call a program that runs Java bytecode instructions? Number 5, if you have a class called myClass in your program, what should the name of the file be? Number 6, if you compile the code from myClass, what will the name of the resulting bytecode file be? All right, and that wraps that up, folks. Until next time.